Hello, my name is Samantha and welcome back to another Embedded Systems workshop. Today you'll be learning about the servo motor and creating a project where you use buttons to control a waving servo apparatus. The slides, schematics, and other resources can be found in the description below. Let's get started.
All right, so today we're going to be going over servos, or more specifically servo motors. So today we're going to learn about what specifically a servo motor is, and learn how to control it. And then our project will be something like what you see in this picture here, and that's use a pair of buttons to control a waving servo apparatus. So go get your kit for this, and let's get into this. All right, so what we're going to be making is a servo. This is our servo project. Use a servo to control rotation with simply the push of a button. So we use just a pair of buttons, and then when you push a button, it'll make the servo wave in one of a couple different patterns. Right. So here's all the parts that you guys are going to need. You're going to need your Arduino. Oh, I'm disconnected. 1 second. All right, you're going to need your Arduino, the USB cable that connects it to your PC or laptop or what have you. You're going to need a breadboard. You're going to need, oh, it came off. You need the servo and a servo horn. What kind of servo horn you choose doesn't really matter. Although Sam, the tape on his arm came off. Tape came off. The tape is coming off. All right, you're also going to need 2 buttons, like these guys here. A bunch of male-to-male jumper wires, which, if you guys remember, those are ones that both have an end, both have a pin on the end. So, like this. This is a male-to-male. It has the metal pin on both ends. And you may need, and if you want to secure the servo horn to the servo, you'll need a screwdriver. And if you want to make a little arm like this, or to just attach the servo horn, you might need some tape and maybe cardboard or cardstock. All right, so let's go over some of the things that we've examined previously. So the things we've gone over previously, like breadboards. So this is just going over how the breadboard is linked along the. And so in the middle section, they'll be arranged in rows of 5, on each side. They're connected horizontally, but not across the middle divider. And on the 2 sides, this is plus and minus, there's going to be linked vertically along the entire length of the board. And once again, they do not cross the middle divider. And of course, it is good practice to have your power input connected to the positive rail, which is marked with what has red on the side of it, like this one. And then your ground pin connected to a negative into the blue rail. And it even has a little guide here. It has a little plus and minus. That's positive and negative. Next thing, which doesn't really apply to this workshop, is resistors, which slow electric current and control where and how fast the current flows. So resistance value is measured in ohms, and the value of each resistor is displayed by 3 or 4 stripes on its body. And each stripe has a different value depending on its color and where it is on the actual resistor. Then we have a potentiometer, which is simply a variable resistor. So again, this is a potentiometer. And I seem to have left something in there. It should not be there. Basically, what it does is just adjust how much resistance is applied. Basically, how much resistance does this resistor have. And I somehow left that in. We are not going to be using an LCD screen for this, so I'll just use that. And it's useful for things like adjusting brightness, power, and what have you. All right, so now into our project. So a servo, like this guy here, it's a type of motor that's designed to allow a precise rotation within a fixed range. The servos we have can go from 0 to 180 degrees. They will not go beyond that. And what position they go to depends on its input signal. And compared to traditional motors, servos differ in the sense that they do not provide a continuous rotation. So the servo here, unplugged. The servo has 3 wires, as you can see here. There's a red wire that connects to your power, or positive, in this case is 5 volts. There's a brown wire that connects to your negative, and that connects to the ground terminal. And then the orange wire is what you use to provide the signal to the servo. Here's a little diagram, just to be clear here. The servo itself is actually, the red wire is still the same. Of course, the yellow wire was replaced. The orange wire that's on this servo was replaced by a yellow one in this diagram, and then the brown wire on the actual servo was replaced by a black one. They still serve the same function, they're just slightly different colors, so just keep that in mind. So first things first, attach the servo horn to the servo. So this is one example of a servo horn. Let me get it out there. So this is an example of a servo horn. Attach that to the servo. Just click it on like that. Just push it on like that. And if you want to fasten it to the servo, there's some screws in your kit, and they will help to clamp the thing down and make sure it just doesn't come loose. Because this is not a secure fit, which I'm not going to secure it, but the option is there if you want to do it. If you're actually building something with this, it would be a good idea to secure that servo horn. All right. Here's a schematic of our project. I'm gonna let you guys go and build that. Yeah. If you have any questions, just ask. Okay. So if you want to, just for now, if you want to, you can leave out the buttons. They will come in handy. They will be used later though. So it may be a good idea to just attach them right now. All right, anybody have any questions so far about how to build the circuit or what the servo does? Just in case, this is just in case anybody didn't see it, this is one of your three. This is one of the three servo horns included in the kit. This is the one I'm using. There are two others. One I think that's a plus, and another that's you don't. What you do actually is, I'll show you here. So these are all. Actually. Let me switch to the dock cam. This should be easier. All right. So this is your servo. These aren't actually covered. These are all female ends of the wire. So what you do actually is you grab one of these male-to-male wires. And you just plug that into one of these three holes. The hole corresponding to the color. For example, I plugged this green wire into the hole into the female end that corresponds to the brown wire, which is going to go plug into my ground rail. Like so. Just reassemble this. Okay. Any other questions so far? It should be a relatively simple circuit to build, assuming these wires don't keep coming loose. Oh. Now, when you're done building your circuit, just type done in the chat. Just type done in the chat. Are we all done building the circuit? Okay. So now let's get into the code for this thing. All right, so we've got a pair of starter codes on our GitHub, which should be on the slides. And you can go to the GitHub by going to these slides and click this link. Yeah. All right. Yeah, and Samantha also posted the link to the GitHub in the chat if you need it. All right, and once you create a pull request, confirm that you should have the lesson 4 folder in your GitHub repository. All right, just a quick review on how to set up the Arduino. So first open Arduino on your desktop. Click File in the top left corner, and then just click Save, and then save it as Servo Test, or save it as whatever you want in this case. Or just load one of the starter codes if you so wish. Then what you do, connect the USB cable that's connected to your computer, plug that into the port here. And it's active now. Oh, that's right. All right, I've already loaded a code onto my Arduino, so this thing is already going. And I feel like I should probably stop it. Uh-oh. All right, I'm just going to disconnect it for now. Out. Then just make sure you go to Tools and make sure the board is recognized as Arduino Genuino Uno. And then the port is going to be COM something. It's usually a random number between, I think, 2 and 8 or something. I've seen them go as high as 9 sometimes. Just make sure the board is recognized as a COM something Arduino Genuino Uno. Now we are going to have to download the Servo library. Unless it's already included in the Arduino, which I think it might be. So in this case, we may not have to do that. I will check just to be sure that it is or isn't included. Yeah, Servo is a built-in library, so we don't need to download that. But it's helpful to know how to download a library. All right, so here's the first starter code, which is pretty dang simple. You could probably write this yourself if you want to. So first, what we do is include the library, include servo.h. And then we initialize the servo. And servo, I just named it my servo. You can name it whatever you want if you're editing things. Just make sure you keep the name consistent. And then we set it up with this line called myservo.attach for, and that sets the pin to control the servo to pin 4, which And if you connected it to a different pin, like say pin 7 or 8, you would change that to 7 or 8. Then all this loop does, all this loop does is it writes the position to the servo. It writes the next position 0, which is going to be the 0 degree position. And then this delay is just here. Make sure it gets to that position before we write a new position, in which case 90 degrees, 180 degrees, and then 90 degrees. This will be just one called servos. This one is brutally simple. Here's your first exercise. edit the servo code here to change the speed of the wave, which you probably do by editing the delays. And then the next exercise you can do is edit this servo code to produce your own movement pattern. And you can add or remove the myservo.writes as needed. This thing is still going. All right, any questions so far? Right. All right, how you guys doing? You guys got the code down, and did you manage to produce your own pattern? Oh yeah, you can just wave the servo at us if you want to. Now, once you just, if you could turn on your camera and wave at us at the servo, that'd be cool. All right. Just want to make sure you guys have this down now. I kind of need a response.
If you guys are uncomfortable with turning on your cameras, you can just send a message in the chat, give a status update on where you are. For instance, if you're still stuck maybe on getting the code or getting the library, or maybe you're trying to get your Arduino connected, any of those is okay. Just let us know. If you're done up to the point where you've done both exercises or your server is working, that is also cool. We've got another set of code that you can try.
Wow, okay. just going to give you a couple more minutes to finish up, then we'll go on to the next little set of code. If the Arduino did not produce an error, that means the code is good. Yeah, so run it. Yeah, so run it. Since it produced that means if you don't get an error code, it means you're good. Oh, did you click upload instead? Did you click upload and where is it? Did you wire things correctly? Just to be sure here, the orange wire on the servo is connected to a wire that connects to one of the pins on the Arduino. I have mine connected to pin 4 just arbitrarily. The red wire on the servo is connected to a wire that goes to pin. It goes to where are these tangled? Yeah. Make sure the red wire is connected to a wire that goes to the power of 5 volts, and then the brown wire is connected to a wire that goes to ground. Just make sure all that is good. Just make sure all that's done. What pin is your servo connected to? Yeah, Renee, just to clarify, just make sure we're on the same page. So your orange wire on the servo connected to, which I'm going to have a yellow wire here, is connected to pin 4 on the Arduino. Your red wire is connected to something that connects to 5 volts. I have that connected to the red rail, and then I have a red wire going to 5 volts. And then the brown wire is connected to a wire that connects to a ground. It connects to a ground. In this case, I have this black wire going here, connects to the blue rail here, and then this blue wire here connects to ground. It's connected to the blue rail. Just make sure that's wired properly. All right. Well, in any case, I'm gonna move on to the next set of code. It's actually more or less the same. And here's another one. This one is called Servo Wave. Basically, what this one does, we have these two buttons here. When you press it, when you press each button, I'm going to upload this code here. You upload the code here. When you press a button, it'll do one of two wave patterns, like so. So all this is actually another relatively simple code. So first things first is we initialize the servo. First we include the servo library, then initialize the servo. Then what we do differently in our setup was we attach it to pin 4. We have a couple of buttons, and we need to. So we have this array here that shows what pins the buttons are connected to. In this case, pins 5 and 6. So the next line here, my servo.write90, that one just initializes the center position of the servo. And then this for loop that sets both pins 5 and 6, which correspond to the two button pins that the servo is connected to in this array here. And that sets pins 5 and 6 to inputs. And then if we go over to our loop, you press this first button, you press one of the buttons, in this case, the button connected to pin 5, since this is button 0, which the first one in that array, the first one in the buttons array is pin 5. That'll produce this pattern here. And then I have this here, this is my servo.write90 to reset it. And then you press buttons 1, in this case it's connected to pin 6. That does a different pattern. And then once again, recenters the servo. Any questions about that? Okay, what have we got here? Wait, hold on. Show me the wires on the servo. You may have connected the wires on your servo incorrectly. All right. So what we have here, let me show you on the dock cam. Oh, that one came loose again. All right, so your orange wire, the orange wire here on the servo should be connected to a wire, which I have this yellow wire. That should be connected to a wire that goes to one of these pins, which in the case of this exercise, that'll be pin 4. Your red wire, which is the middle one, that needs to be connected to a wire that needs to be connected to the 5 volts, which I've done through connecting it to this red rail here with this green wire. It's the red rail, and then the red rail is connected by this red wire to 5 volts. And then your brown wire over here, that should be connected to a wire that should be connected to ground. Which in this case, I've done it by connecting it to this black wire, to my blue rail, then another wire connects that to the ground. Just make sure all that is done.